Okay, in this demo, I'm going to talk about the work that we've been doing to port the Netflix open source platform for cloud over to the IBM SoftLayer cloud. I'm going to cover 4 points. I'm going to cover porting the services and web app runtimes over to the Webster Liberty Profile application server and IBM Java. And those Netflix components would be Karyon and Ribbon and Hystrix and the Eureka client. Then I'm going to showcase the porting of the location services, Eureka, and how we ported that to SoftLayer. Then I'm going to show the auto-scaling groups and how that was moved over to IBM SoftLayer and RightScale, as well as the management console for those auto-scaling groups, which is Asgard, again over to the SoftLayer cloud plus RightScale. Finally, I'm going to show HA and prove that it works through the Chaos Monkey, and we're going to show how that's been ported over to IBM SoftLayer. So first, let's start with the server runtime overview. This is leveraging the Acme Air application, and you can see the Acme Air application takes browser clients, either mobile phones or tablets or desktop browsers. It comes through a front-end web application and calls a microservice for authentication, and then that talks to a data tier. What we've done here is we've broken that up following the architecture for using Ribbon as the REST client, using its internal load balancer based upon Eureka to talk to that auth service, and having that wrapped in fault tolerance of Hystrix, that it can do a circuit breaker pattern on top of calling that dependent service. Both servers, the front-end web app and the back-end auth service, start up in Karyon as a container, and that is running on top of the Liberty application server, on top of IBM Java, on top of the SoftLayer IaaS layer. So let's go ahead and show you that. So the Acme Air application is a pretty simple web application. So I'm going to go ahead and log into it. I can look at my account information. I can search for flights. Now each one of these calls is authenticating that I am currently logged in, and since the front-end web application is completely stateless, it's calling that authentication back-end service that I showed in the diagram on each and every web request. So I went ahead and booked those flights, and now if I look at my flights, I can see that I've got a bunch of flights and I can cancel bookings. So pretty straightforward web application. Now what I'm going to do is I'm going to start up, actually it's already running, but I'll restart it. This is a load generator. It's pretty simple. It's just going to start up 10 concurrent users. That's going to do the same thing that I just did in the web application, but it's just going to run throughout the rest of this demo. So it can show you what happens as we do various things to the infrastructure. So you can see it'll also record in this column here how many errors that it's seeing, what percentage of the overall workload does it detect an error. So to just kind of show you here, this is tailing the log file, but you can see that I'm running 2 different servers. These are running on top of the SoftLayer cloud. You can see that they're running IBM Java and they're running Webster Liberty, and you can see the first is the Acme Air web application, and it's going through Archaius properties to pass that in, and you can see the second one is running the auth service. You can see load is hitting it now, so the front-end web app takes most of the work, so you can see that it's running at like 90% CPU or 2 or 3% idle. Whereas the middle tier is service is running, about 13-14% utilized. I'm going to go back to tailing the log files of each of these servers, just in case if we see any errors. Those errors you just saw there were from the first request. There's a bug we're still working through on that, but after the first request, that sort of goes away. You can also see that the backend data tier here is our data grid product, WebSphere Extreme Scale, and you can see it's taking about 13% CPU. So every single web request at least makes one call to the data tier, if not multiple. You can see right now, if I look at how my data is placed around that data grid, it's going to tell you that there's one container for the data. Only one instance is currently, it's not very HA right now. It's only holding one server is holding the data, and all 13 shards of the data are on that one server. So let me go over to the slides again. So now we've covered the runtime infrastructure. So again, the big portability changes here are that we moved it to the WebSphere application server and running it on top of IBM Java, all on top of the IaaS layer that is SoftLayer, as compared to OpenJava, Tomcat, and the Amazon cloud, which Netflix would run on currently. So the second thing I wanted to show here was another port that we made. Once you adopt the microservices architecture, there's a naming service that gets involved for discovery. So when this front-end web application comes up, it has an internal load balancer that says for each instance of the web app, it needs to find all the authentication services that are in its availability zone, so it knows which ones to call. That's not done through a router, it's done load balancing actually in the client. So that client, when it comes up, needs to discover what authentication services exist. And what we've done is we've actually re-implemented Eureka within the networking configuration of the IBM SoftLayer cloud. We did the DNS text record approach that Netflix uses, but we did it through the DNS that SoftLayer provides, and we made some changes to how the discovery of the nodes occurs. So when the authentication service comes up, Karyon kicks in, and the Eureka code will register into Eureka what the address is of this authentication service. So let me show you that in action. So I've come over here to my Eureka console. In fact, let me show you kind of under the covers right now. So this is the SoftLayer management console, and you can see right down here we've got an HA configuration of a Eureka. So we've got 2 instances in the Dallas data center and 2 in a San Jose data center, and they're all linked together. In fact, if I come up here and look at the Eureka console of one of these, you can see we've actually got the self-preservation mode turned on. You wouldn't want to do that in production, but for the small amount of services that we have, we don't want it to start thinking that the network's down just because a large percent disappear as we start to make instances go away. So that's why you see this warning up here. But you can see they have the replicas that are registered across the 3 other than this Eureka server. And you can see that they're all registered with each other, so they know how to communicate with each other. You can also see that in the current configuration, we've got 1 instance of authentication server and 1 instance of a web application server. As I said earlier, we had 1 instance of the data grid server. We kind of call this a 1x configuration. So at each tier of the application, there's 1 server. Again, not very HA, but it's the beginning point for how you would replicate to a larger cluster. So next I'd like to show you how we do HA of the applications and elastic scaling of the applications. But first we'll start with management. So in the Netflix stack, the management console is a program called Asgard, a server called Asgard. And what we're going to do, what we start with is the concept of an auto-scaling group. So that's an EC2 concept, but there are other implementations of that I'm about ready to show you. So an auto-scaling group right now we have 1 instance of the web application in a group, we have 1 instance of the auth service in a group, and we have 1 instance of the extreme scale container, the data grid in a group. So let me go over and show that console to you. So this is the default console. So what you can see here is I'm clicking around and looking at concepts within the EC2 cloud. So this is Amazon. It's pointed at US East currently. I can see the AMIs that I have. I can see the instances that I have. And I can see the clusters or auto-scaling groups that I have in my application. Now what I'm going to do is I'm going to switch over. This is part of the portability work. So I'm going to switch over to a different region that's defined as SoftLayer 1 in Dallas. So you can see that now it switches over and says, I'm looking at that part or that region. So I'm actually managing with the same console services within EC2 as well as services within SoftLayer. So if I come over here and look at AMIs, so this would be images, and I can not filter it down. You can see I have lots of images. I can go look at one of my application images. So if I look at the image for my container, you can see what the image is. I can go and look at instances. And let's not filter that. You can see that I have lots of instances in various states. I can also come over here and look at my cluster. So as I said, I've got my driver machine, which is running load right now, running to a single instance of the front-end web application, running to a single instance of the auth service, running to a single instance of the data grid. And these are all in auto-scaling groups that are currently sized at 1. So if I look at, say, the front-end web application, you can see its instance bounds right now are 1 and 1. One thing I haven't covered here, and you'll start to notice it in sort of these tags, what we are doing is we're leveraging a business partner for the capability of auto-scaling groups on top of SoftLayer, and that business partner is RightScale. So RightScale has a concept of server arrays based on server templates, which is fairly similar to the concept of auto-scaling groups and launch configurations within the EC2 cloud. So we're actually managing those server arrays on RightScale as connected to the SoftLayer cloud. So through this console we can manage our auto-scaling through RightScale and our underlying IaaS resources through SoftLayer. So the other part of, when I say auto-scaling, the other part of auto-scaling is the information about how a cluster is running. So I've got a cluster defined here in the console. You can see for any one of these, I showed you already, it was a minimum of 1 and maximum of 1. Diving under the covers, I said RightScale is sort of in between. I can look at that same thing and see that right now this authentication server array is defined as 1 and 1, and that's what the console on top is showing you. And you can see that over time it is actually done through performance monitoring and instance monitoring. It's been resizing the array up and down based on whatever size I've had it at the time. And it does that through similar concepts to CloudWatch monitoring over in the EC2 side, but all implemented in the images that are running in SoftLayer and the monitoring services that are available through RightScale. One thing I won't show in a demo, but I'll kind of just allude to here, is the DevOps support. But what I can show you here is not only can I look at a single version of the cluster information, I could also look at the cluster itself and say, so I could also look at the cluster itself, and you can see here I've got a version of the cluster for the auth service running with a known version of the image. I could actually decide that I have a new version of the code, and I could go ahead, let's see, find one. If say this was the newer version of the code, I could go ahead and create a new auto-scaling group around that newer version of the code. I could end up having these both running simultaneously and have them as both active. I could look at how well this one is behaving. If it's behaving well, I could start ramping up the number of instances in a new version of the code and ramping down the instances in the old version of the code. I could actually disable it, stop sending traffic to it, and have it there. So as this thing gets up to scale, if it has any kind of issues at scale, I could quickly fall back. And all of that is enabled just by supporting the underlying concept of auto-scaling and enablement through the console that's already done here. But I'll save that for another demo. So moving back to the slides, I next want to show elastic scaling. So far I've shown you this at a fairly boring sort of 1x configuration of one web app driving one auth service driving one auto-scaling group. Let's show how this all works together. So what I'm going to do is I'm going to scale up these auto-scaling groups, and it's going to register through Eureka that the newer instances exist, and Ribbon is going to get that information and start load balancing across. So all the pieces kind of come together to create a very elastic infrastructure for this overall application. So the first tier I think I'm going to change is, let's go into the data tier. So WebSphere Extreme Scale is pretty good at this in terms of being elastically scalable as you add and remove containers. So let me go ahead and go in here. And instead of having this defined as a min of 1, a max of 1, let's make it a min of 2, a max of 2, and a desired capacity of 2. You'll notice there's some places in the console here now that you're in the SoftLayer region where it will say things like fake config name and things that look like they're stubbed out data. And the reason for that is there are some concepts that don't make sense as you move outside of the EC2 environment. And the next step for portability would be to generalize this interface to support multiple clouds as opposed to just what we've done thus far, which is enable sort of the bottom edges of this application to deal with multiple clouds. So you can see what it did here was, with the same image that it had before, now instead of running one instance, it's running two instances. So what we should expect to see here is, if I go sort of under the covers, you wouldn't need to do this, but I'm just showing you technically what's happening under the covers. If now I come into that same server array, you can see it only has one instance currently, but if I go in and look at its definition, what changing that through Asgard has done has now changed the policy to be a min and max of 2. And what should happen is you should start to see an audit alert get kicked off when it realizes that the array is needing to be resized by 1. And there you go. So you can see that it has now realized that it needs to resize the array by 1. So now if I come into instances, you can see now it is starting up a second instance for the container tier. And now diving even deeper under the covers, what that is doing is RightScale is contacting the SoftLayer cloud, and it should be starting up another instance. So you can see right here, it's got another instance that is now coming online that we went all the way back and we managed this from the Asgard console in terms of being able to create IaaS resources on the fly based on elastically scalable cluster definitions. Okay, so it looks like that instance is just about online. So I'm going to come over here to my Extreme Scale catalog server, and I'm going to again show the placement. So what should happen is, yep, it already has happened. So you can see what happened is another container server has come on, and it's taken half of the shards away from this other one. And you can see it actually has taken half of the work away as well, so it started to share the work. So whereas before it was running at about 86% idle, now it's up to 92% idle. So the other instance is now taking on half of the load. And if I come back to the workload driver is still happily cruising along with no errors. It didn't notice that the backend service has gotten more capacity. The front end is still the bottleneck, so it didn't actually increase the throughput, but it did decrease the load on the backend servers. So now going back to the diagram, we've scaled up the backend tier, but that didn't involve load balancing between these two services. So let's go ahead and scale up the authentication service. Now, to start out, let's show you the state of the network. So you can see, as before, that there's one authentication service and one web application. So when this web application on 10.62.2.3 contacts the auth service, it only knows to call this one currently. So I'll come in here to the cluster for the authentication service, and much like with the extreme scale container, I'm going to go ahead and edit that, and I'm going to make the capacity now of that as 2 instances. Okay, and again, showing you sort of under the covers here, I can go ahead and look at that array in RightScale. And you can see currently the authentication server only has 1 instance. And we should be able to see in the audit entries. There's been a lot of history here as we've been playing around with this array. If we wait a couple seconds, so you can see that now we've got the resizing the array by +1 again, going from 1 instance up to 2. So we come in here to instances, you'll see we've got our 1 operational and 1 is pending, so it's kicking off the next instance. Again, looking under the covers in SoftLayer, you can see that RightScale has gone off and kicked off this new instance, ready to do the work of a new authentication service in instantiation. I'm going to try why this runs. I'm going to grab its IP address here. And while this is getting kicked off, what I'm going to try to do is catch it as it boots up. To explain a little bit about how it registers itself into the network. Okay, so let's try to catch it as it's booting up here. So this image tells it to start up an authentication service on WebSphere Liberty through a startup service. And if I look at the log files, maybe we can okay, so here we go. WebSphere Liberty is starting. It's connecting to extreme scale, finding the REST services, and the application is up. And now we'll wait just a few seconds, and Eureka, the client, should go register itself in the Eureka service in the registry. Okay, so it should have registered itself. So if I come back here and look at my Eureka view, now you can see I have a second authentication service. And you can see that I haven't gotten any errors. My clients, 10 clients, are still happily running along. We should notice that the utilization, there again is that first request error, but it should clean itself up after the first request. You should see, and there it goes. You can see that the other authentication service, the one that's running already, has now started to take on half the load. because this new instance has started to take on half the load of the old instance. So now I've shown you elastic scaling. The last thing I want to show you is automatically handled high availability. The auto-scaling groups are interesting in how they can allow you to, as I showed you, either manually elastically scale or through scaling policies automatically elastically scale, but they're probably even more interesting in just their ability to handle HA. In the Netflix infrastructure, they actually test for HA. The way they test for HA at the sort of lowest level is something called Chaos Monkey. So what we're going to do here is simulate that one of these all services that we just brought up, either the original one or the new one, dies. So say that instance gets killed, or that availability zone goes down, or something along the lines where, you know, that thing is now gone and people can't talk to it anymore. We're going to use the port that we did of Chaos Monkey that will actually go into the SoftLayer cloud APIs and will actually kill with extreme prejudice the service, that either the old one or the new one. So I'm going to SSH into my Simian Army machine, and I'm going to look at look at the configuration. So what you can see here is I've got a Simian Army that has a Chaos Monkey defined, and you can see that it's defined that it's going to, for the auto-scaling group of the authentication service which we were just working with, that the Chaos Monkey is enabled against that service. It is a probability of 6, which out of 6 times, how many times it's going to kill things, so 100%. It's also notifying me through emails when it does this, so I need to have my code written in such a way that it handles this well, but I'm still going to get an email that says, hey, the monkey just decided to kill your instance. You might want to go check on it and make sure that your code behaved as you expected it to, that i.e. it kept running. So what I'm going to do, this is again on SoftLayer, I'm going to go ahead and start up the Simian Army. And you can see that it went and started up. This was from a previous run. It came up and it said, I've terminated instance ending in .200 from that auto scaling group. So what it did was it just called down to the SoftLayer APIs and said, act like that instance just got shut down without any sort of warning. So this instance here, it's still in Eureka because it hasn't gotten a heartbeat, it hasn't timed out the heartbeats yet, so it still thinks it's there. And what you can see is we got 26 different errors when that occurred. So there were probably about 26 requests that were in flight to that backend machine that got terminated along with the instance being terminated. And what's happening here is Ribbon has seen that that instance is dead. Hystrix has probably kept going because part of the instances is still working, but Ribbon has taken that guy out of load balancing between the web application and the service. So at some point he will disappear out of Eureka, but that's okay if he doesn't. All the clients have their own cached information about what they know to be up and what they know to be down. So Ribbon is now acting like this one does not exist. But what's more interesting here is, remember I set this up as 2 instances. So if I look sort of under the covers again and look at the arrays, you would expect the auth service to be set up for 2. And this one is the one, I believe, the last one that came up is the one it decided to kill. So pretty soon here, the server array is going to realize that that instance is gone. and we'll look at audit alerts. This is our previous resize by 1. As we were just manually scaling it up, we should expect that it's going to have an audit alert that says, oops, we need another one because something happened to the one, and for HA reasons we need to bring this one back up. You can see right now it just realized that somebody terminated that instance that it was tracking. And you can see now it has gotten the attention of the autoscaler that's saying, hey, now we're only down to 1 instance. We're supposed to be up at 2 instances. Let's kick off another one. Let's look back at our load generator. Still getting a few errors. I have to figure out what that is, but still getting a few errors, but not bad. I need to figure out why it hasn't totally shut down the number of errors, but you can see we're at 0.1% of errors. And the system is starting to recover from the problem. If I come over to Eureka, you can see Eureka has now taken it out of the discovery service, so any new people looking to see if that instance was there are not going to see it. But we're back to, as far as the system knows, only 1 auth service, while the auto-scaling is bringing that back online. Again, sort of behind the scenes, what you can see is you should see 1 coming online here. Yes, so you can see that RightScale has decided to scale it up, and again it has created another instance. Now, this time it wasn't because I manually told it to elastically scale. This is because an instance died and we want HA, so the system itself recovers. So I could keep watching it here sort of in the under the covers view, but let me jump all the way back to the top level view that most people would stay in the view of. So if I come back and look at the cluster and I look at the auth service cluster, what it should tell me that there's 2 different instances. You can see the launch time of the latest one being a couple minutes ago, and that's the one that's auto-recovering. If I go into that instance, I should be able to see what its public IP address is, and I should be, again, able to kind of watch it as it boots. I should also be able to watch it from this perspective. If I look at the off-service instances, you can see that we're still waiting for that instance to come up. The original one is still operational, but there's one in pending state waiting for that one to boot. And he should be coming up right now. He should be booting up, and I should be able to watch within Eureka. And there he goes. He came back on. So he's at this point automatically recovered from who knows what that killed him. And if I come over here and watch, you can see that this guy, the authentication server, the original one, should start to take on a little less load. So what we showed here in terms of portability is the Netflix open source platform for cloud running on 4 different areas. The main runtime aspects of the web applications and microservices running on the WebSphere Liberty profile application server and IBM Java. The mid-tier services and their location services to find each other, porting that over to the SoftLayer cloud. The auto-scaling groups, both for elastic scaling and for HA recovery, as well as DevOps procedures in terms of rolling new code changes. All of that using, instead of auto-scaling groups on the Amazon cloud and the Asgard console talking to Amazon, now the same Asgard console working across multiple clouds and talking through RightScale to IBM SoftLayer. And then finally, being able to prove that HA works through HA testing tools like Chaos Monkey that have been ported over to the IBM SoftLayer cloud. And it showed us that we could have a very elastic runtime that was very fault tolerant and can prove that fault tolerance, and that it could be managed by a developer in a DevOps sense from the Asgard Management Console. Thanks.